Lesson 4-7, use congruent triangles. In this lesson, we're going to take one step further with proving triangles congruent by stating that their corresponding parts are congruent. And the reason that we will use for this is CPCTC, meaning corresponding parts of congruent triangles are congruent. This is in your book on page 256, and there's a explanation of this, and you can go ahead and read the first example and write out the entire phrase. Now, given angle 1 is congruent to angle 2, and AB is congruent to DE, I want to prove that DC is congruent to AC. Now, I need to first explain or provide a reason of how to prove angle DEC is congruent to angle ABC by using the congruent supplements theorem. So let me first state the given. Angle 1 congruent to angle 2, AB congruent to DE. And now I can say that angle DEC, this one, is congruent to ABC, angle ABC, by the congruent supplements theorem. So these two angles are supplements, and they're congruent to the same angle. Therefore, these two angles have to be congruent. And now I can say that these two vertical angles, angle DCE is congruent to angle ACB by the vertical angles theorem, congruence theorem. And since two corresponding pairs of angles are congruent and a non-included side is also congruent, angle, side, angle, side, these two triangles are therefore congruent to each other. So I can just use this reason. And since these two triangles are congruent, then all their corresponding parts should be congruent. So therefore, I can state that DC is congruent to AC. And I would like you to use CPCTC. Okay, I would like you to make some changes to the second example here. Okay, please cross out these given information and change the second reason to base angles theorem, which is covered in the next lesson. And I will explain this a little bit when I prove this. And the reason why I'm doing this is because I want to save some steps. The original proof is a little longer. So given here, angle SPT is congruent to angle RQS, and ST is congruent to RT. So I could first write given. And since ST is congruent to RT, I can say that their opposite base angles are congruent. And this is based on the base angles theorem. When you have an isosceles triangle, then their opposite base angles are congruent. So I can, for the next step, I can write angle PRS is congruent to angle QSR. And for the next step, I can state that SR is congruent to SR by the reflexive property, because right now my goal is to prove this triangle congruent to this triangle, because I want to prove PR congruent to QS. So now for the next step, I can write, triangle PRS is congruent to triangle QSR. So again, triangle PRS is congruent to triangle QSR by the reason of angle side. So angle, and another congruent angle would be this one. Angle, 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 and then they share this side. So then, since these two triangles are congruent now, I can therefore state PR is congruent to QS by the reason of CPC/TC. Example 3. Given that angle 1 is congruent to angle 2. Angle 3 is congruent to angle 4. And I want to prove triangle ABD, so this one, is congruent to triangle ACD. Now before I prove these two triangles congruent, I will need to first prove these two triangles congruent. So I'm going to first state my given. Angle 1 is congruent to angle 2. Angle 3 is congruent to angle 4. And DE is congruent to DE by the reflexive property. And since angle 1 and angle 2 are congruent, and I need to prove these two angles congruent, and since these two pairs are supplementary, and these two angles are congruent to two congruent angles, then by the congruence supplements theorem, we can state that this angle and this angle is congruent. So it will be angle BDE. So this is angle D here. Is congruent to angle CDE. So now I have angle side. So I proved these two angles congruent as well. So angle side, therefore triangle BDE is congruent to triangle CDE, which is already stated. So our reason again is angle side. And therefore BD would be congruent to CD by the reason of CPC/TC, corresponding parts are congruent. And again, AD is congruent to each other. So we have reflexive again. And since we already know that angle 1 is congruent to angle 2, and our goal is to prove this triangle congruent to this triangle, so by side angle side, then triangle ABD is congruent to triangle ACD. Example 4. Given that GH is congruent to KJ, so it would be GH congruent to KJ, and that angle FJG and angle LHK are right angles, and we want to prove that triangle FJK, so this one, is congruent to triangle LHG, this one. So for the first step, I will write given. And for the next step, I will write HJ is congruent to HJ by the reflexive property. And it is pretty much implied that if GH and KJ are congruent to each other, and HJ is congruent to HJ, then GJ would definitely be congruent to GJ would be congruent to KH. So here I added these steps in here. So if I don't limit you and I really want a detailed proof, I do expect you to show all these steps. So for step 3, I stated that GH is equal to KJ and HJ is equal to HJ, and this would be by the definition of congruent segments. And for step 4, I will use segment addition postulate. I stated that KH is equal to KJ plus HJ, and I did the same for GJ. And then for step 5, I substituted GH from step 3 for KJ, so then I can say KH is equal to GJ by substitution. So both steps 5 and 6, we can say their substitution. And then I need to change it back to congruence form, so definition of congruent segments. So then therefore, by the time you get to step 8, we can state that triangle JFG and triangle HLK are congruent by the HL theorem, because this side is congruent to this side, and this side is congruent to this side is congruent to this side, and these two are right triangles. So we can therefore state that FJ is congruent to LH by CPCTC. And we can also say that angle KJF and is congruent to angle GHL by the congruent complements theorem. So therefore we can say triangles FJK is congruent to triangle LHK side angle side congruence. Example 5. Write a proof to verify that the construction for copying an obtuse angle is valid. So given that AB is congruent to DE and AC is congruent to DF and BC is congruent to EF. And we want to prove that angle D is congruent to angle A. So again, we write the given. And since all the sides are congruent, triangle CAB is therefore congruent to triangle FDE by side postulate, and therefore the corresponding sides are congruent. Angle D is congruent to angle A by CPCTC. Okay, and we'll continue more proofs in class.